Hey everyone, in today's video we are going to dive into one of the most efficient and widely used sorting algorithm, quicksort. Quicksort is a powerful sorting technique based on the divide and conquer principle. We'll walk through it how it works step by step. So let's get started. Quicksort operates in three key steps. The first one is choosing a pivot. The pivot is an element that helps split the array. It could be picked by selecting the first or last element of the array. The second is partitioning the array. We divide the array into two parts. One part contains elements smaller than the pivot and the other part contains elements larger than the pivot. Now let's break down an example so you can see quicksort in action. Suppose we have the array 21, 3, 5, 13, 14, 1, 6, 8. We'll pick the last element 8 as our pivot. To partition the array, we use the partitioning algorithm. Here's how it works. We start with two pointers. Pointer I at -1 to track elements smaller than the pivot, and pointer J starts at the first element and compares each one to the pivot. First we check each element one by one. Let's go through them. So the first one is 21. 21 is greater than 8, so we do nothing. The another one is 3. 3 is smaller than 8, so we increment I to 0 and swap 3 with 21. Next is 5. 5 is smaller than 8, so we increment I to 1 and swap 5 with 21. The next is 13 and 14. 13 and 14 are both greater than 8, so we skip them. Next is 1. 1 is smaller than 8, so we increment I to 2 and swap 1 with 21. Lastly, 6 is smaller than 8, so we increment I to 3 and swap 13 with 6. After comparing all elements, we swap the pivot 8 with the element at I plus 1, which is 14. Now the array looks like 3, 5, 1, 6, 8, 21, 13, 14. The pivot 8 is in its correct position and the array is split into two parts. Next we apply the same steps recursively to the left and right subarrays. We keep repeating the partitioning process until each subarray has only 1 or 0 elements, and at that point the entire array will be sorted. As you can see on the screen, the array is already sorted and we have the final result. Now lastly, I tell you about the time complexity, but if you're not familiar with it, I recommend going through it so you can understand quicksort in more depth, as this video is only here to explain about the quicksort. To give you a quick overview about the time complexity, I would explain about best, average and worst case. In the best case, the time complexity is order of n log n when the pivot divides the array evenly. In the average case, the time complexity is also order of n log n, which is the most common scenario. And lastly, in the worst case, like when the array is already sorted or when the pivot is poorly chosen, the time complexity can degrade to order of n square. And that's quicksort. It's a simple yet powerful algorithm that works great for most scenarios. Thank you for watching.